our final lesson in 1.2 on transformations of graphs. In this lesson, we'll look at stretching, compressing, and translating all together in a combination. So we'll graph multiple transformations. Let's take a look at example 1G on the right. The graph represents f of x. And if we look at that picture, notice it isn't linear, quadratic, or even absolute value. It's just a unique looking shape. It says using y equals f of x, which is just our equation, so there's nothing really you need to worry about there. How can you graph a combination of transformations? Graph y equals negative f of x plus 2. Well, let's first describe what's happening here. I see a negative out in front, and what that's going to indicate is whatever we do for our equation or our picture, the graph will reflect over the x-axis. And that means we make y the opposite sign. So I'm going to put a little negative right in front of that. And then we have x plus 2. If we have x plus 2 in the parentheses, we'll move 2 to the left, which actually means we'll subtract 2 to get our ordered pairs. Well, now let's see how we can manipulate all these values. What I'm going to do first is I'm going to make f of x, and I'm going to create a table for values. Because if I look at that picture, I can't use an equation to model all of that information. I'm going to start on that left-hand side. That ordered pair is negative 4, 2. So I've got an x value and a y value. And then as it goes up, I've got a turning point at negative 2, 4. And then it drops down to negative 1, looks like 3. And then you see it extends all the way up to that top point right there, negative or positive 1, 7. So I have a column for x's and a column for y's. For my new graph, I'm going to take my x's and subtract 2 from them. So if I do negative 4 minus 2, I get negative 6. If I do negative 2 minus 2, I get negative 4. Negative 1 minus 2, negative 3. 1 minus 2, I get negative 1. And then I'm going to take my y values, and I'm going to just make them negative. Oops, I need to make that a little bit bigger, don't I? I want to put the negative in front of the y, so I'm just going to write my y a little bit further to the right. But I want to make all my y values negative. So that means instead of positive 2, I have negative 2. Positive 4, negative 4. Positive 3, negative 3. Positive 7, negative 7. So just like that, by kind of manipulating our table, we have new ordered pairs. If you plot those ordered pairs, we'll see if that matches our description. All right, let's see how you did. If we take a look at our original graph in blue, it looks like we reflected it upside down and we moved it over 2 to the left. So that would describe that transformation. All right, let's try the next one. Y equals 1/2 f of x plus 3. Let's see if we can describe this transformation. 1/2 on the outside means our graph is going to compress by a factor of 1/2. If it's on the outside, it compresses by the same amount. That means all of our y values we're going to cut in half for our new function. And then we have plus 3, that's after the f of x, so it's not in the parentheses. The entire graph is going to move up 3. So we'll add 3 to y. All right, let's use our original table. If we take our original function, negative 4, 2, negative 2, 4, negative 1, 3, 1, 7, and create our new function, notice none of our x values are going to change. They're going to stay the exact same. We have negative 4, negative 2, negative 1, and 1. But our y values, we're doing two things to those. We're first going to multiply the original y value by 1/2, and then to move it up, we're going to add 3 after. So I need to extend that a little bit more. I'm going to take each y value and plug it in following my order of operations. If I start with 2, 1/2 times 2 is 1, and 1 plus 3 is 4. 1/2 times negative 2, oh sorry, wow, 1/2 of 4, I'm off on my game, here we go. 1/2 of 4 is 2 plus 3 is 5. Sorry, you guys. Take the next y value, 3. Half of 3 is 1/2, plus 3 would be 4.5. For my last point, take 7. Half of 7 is 3.5, plus 3 becomes 6.5. All right, let's see if we've made this graph compress a little bit and move up a little bit. Plot your points and we'll see how it went. Does your graph look something like this? So notice from bottom to top, we've compressed it. It's not quite as tall as the original function, but we didn't do anything horizontally. It's just that vertical compression. And everything seemed to bump up 2 units even though it's smaller in shape. On this side, it says graph the parent function f of x equals x squared. Then describe the transformation and sketch the graph of g of x equals negative x minus 2 squared plus 5. So we know what the shape looks like for f of x. We've seen the picture, but we haven't actually graphed it yet. So let's take a look at making a table, and I'm going to put it a little bit further down below. That way, when we graph our transformation, I can put my table right next to it. So this is f of x equals x squared. I'm going to plug in negative 3, negative 2, negative 1, 0, 1, 2, and 3. And I'll show you why in just a minute. Notice all those values, we're going to square them for our output. So negative 3 squared is 9. Negative 2 squared is 4. And remember, this is a 1 right here, although it doesn't look very nice. Let's fix that. We'll make that negative 1. If we square negative 1, we get positive 1. At 0, we get 0. And remember, this is the vertex to our function. And then if we go to the right, on the x-axis, 1 squared is 1, 2 squared is 4, and 3 squared is 9. Plot those points and see if your shape looks similar to the picture in our 1.1 notes for the parent function. All right, it might not be perfect, but it looks pretty similar to the one in our picture from lesson 1.1. The next thing we'll do is we're going to describe our transformation. We have a lot happening here. The negative is going to reflect over x. The x minus 2 is going to move right to. That's a move. There we go. Move right to. And last but not least, that plus 5 will move everything up 5. So now in our new table for our transformation, let's see how this affects our x's and our y's. For our x's, we said it's going to move 2 to the right, so that means all of our x values, we're going to add 2 to them. So I'm going to do that column first. Negative 3 plus 2 is negative 1. Negative 2 plus 1 is 0. Negative 1 plus 2 is 1, and it's just going to keep moving to the right. Whoops, I wrote 2 twice. That's fun. I wrote 2 times. All right, that's enough. And then 4, let's see, where am I at? There, and 5. There we go. We've got all of our transformations 2 units to the right. Now let's take a look at what's happening to our y values. We said it reflects over x, so that means we're going to make our y value negative. And then it moves up 5. So order of operations, we multiply by the negative first, and then we add 5. So I want you guys to do that. Take all the outputs in our original function, make them negative, and then add 5 to get your new function. Before you graph it, let's make sure we have a match, and then we'll sketch our graph. Oh boy, this is interesting. Look at all these numbers. -4, 1, +4, 5, back to 4, -1, and then -4. All right, let's plot each of these ordered pairs one at a time. And our goal will be for our picture to match what we said in the description. Plot those points and then press play. Look at the points we plotted. It appears it's going to go in the opposite direction. That's good. And it appears we moved things around. So to connect these dots, you're going to want to continue them all the way to the edge of your graph with arrows now at the bottom. And hopefully your graph looks something like this when you're done. So notice it reflected over the x-axis. It opens in the opposite direction. And look at where that vertex is, that new point. It went 2 to the right and up 5, even though my pen is all over the place there. So the new vertex went from 0, 0, 2 to the right, and up 5. And our axis of symmetry, if we were to draw that in, I'm going to pick a different color just so it's easier to see it, I hope, should be right at 2. So it's going to go right through the middle, right here. And everything on the left side and right side, I'm going to write axis, x equals 2. Everything on the right side and the left side should be symmetrical. Let's try one more transformation. And this time we'll change it up with absolute value. The first thing we're going to do then is plot a table for our absolute value function. So I'll have x and y, and this is f of x. The points we'll pick, now I'm going to just go crazy on this one. I'm going to start at -10. I know, but I'm not going to do every point. I'll pick -7. I'll pick -3. Pick -1 and 0. And then I'm going to do 1, 3, 7, and +10. I know, that's a lot, but we'll be okay. The great thing about absolute value is that no matter what you plug in on the inside, your output is going to be positive. So if I plug in -10, the absolute value is +10. -7 would be +7. -3 is +3, and so on. If the inside is positive, the output stays positive. Go ahead and plot from edge to edge the sketch of the graph for the parent function of absolute value. Your graph should look something like this. And now I'm really going to put you to the test. Now I want you to try your best to complete the transformation. We have a 1/2, we have x plus 4, and we have -3. Can you manipulate all of those transformations to create a new table and sketch your new translated function? Try your best. Once you feel you've done the best you can do, press play and we'll see how it went. Oh boy, let's take a look at what happened here. That graph looks crazy. Notice it doesn't maintain the same shape, and there's a reason for that. The 1/2 compressed vertically, and anytime you have a stretch or compression, the graph will change shape. Notice everything moved 4 to the left and down 3. We have a new vertex at that location. 4, -3. We also have a new axis of symmetry. It moved all the way over to split that in half at -4. So that's x equals -4 for that axis of symmetry. The last thing you see in this set of notes is the transformation set of rules for all transformations from lesson 1.2. Whether it's a vertical or horizontal translation, a reflection, a stretch, or a compression. So this little chart is kind of a quick reference table for you as you perform these transformation rules. And this is the end of lesson 1.2.